Hello everyone, welcome back to our chemistry class. So we are still in chapter 3, periodic table. So this is a video for periodicity part C. So in this video, we will be talking about the variation in atomic radii across the transition element. So the first question that I want to ask you, what is transition element and where is it located in the periodic table? So as you can see there, that is the location of the block. So transition element is actually located at the D block and it is only started at period 4. So the first row of transition element is in period 4, as I said before, in which it is started with scandium all the way to zinc. The graph shows the relationship between the atomic radius of transition element and their proton number. So as you can see in the graph, the atomic radius just have a small difference between them from scandium all the way to zinc. Why is that? So first, let's take a look at the proton number of each of the element. So as we can see, the proton number is in increasing trend. Okay? So when we write the electronic arrangement of each element, we can see that the number of shell of all element is the same, which is 4. And most of the electron is being added to the 3D orbital. Okay, now let's take a look at the inner electron, where from left to right of the period, the inner electron is increasing, while the Z remains constant. When we look at the number of shell also, the number of shell remains constant. So across the period, when we look at the atomic radius for the transition element in period 4, it does not change significantly. Why is this happening? So this is because across the first row of transition elements, electron is added to the inner 3D subshell. Okay, while the number of electron in the outermost shell, which is 4s orbital, remain constant. So the inner 3D will shield the outer 4s electrons from the nuclear charge more effectively than the outer shell's electron. Okay, therefore the Z is being cancelled out by the screening effect of the electrons in the 3D orbitals, and the outermost shell experience similar force of attraction to the nucleus because the value of Z is constant. That's why the atomic radii do not change very much. Okay, so when we look at the graph earlier, we can see that there is a slightly increase in atomic radii at chromium to manganese and also at copper to zinc. Okay, why is this happening? Okay, so to explain this, apa yang kita kena buat adalah kita kena tengok dia punya electronic configuration. So untuk chromium dan juga manganese, electronic configuration dia adalah Ar3d5OS1 dan Ar3d5OS2. So kalau kita nampak di sana 3d5 itu adalah half filled orbital. Okay, so the atomic radii increase from chromium to mangan due to more effective shielding effect. Macam mana dia lebih efektif? Sebab there is an increase in electron-electron repulsion as the 3D orbitals become half occupied. Dalam erti kata lain, 3D orbitals itu are half filled with electron. Next, when the atomic radii increase from copper to zinc, the first thing that we need to do is to write the electronic configuration for copper and also zinc. So, copper punya electronic configuration adalah Ar3d10 for S1, lepas tu untuk zinc, Ar3d10 for S2. So, when we look at the 3D orbital, we can see that it is a fully filled 3D orbital. Okay, so bila kita tengok kenapa atomic radii increase from copper to zinc, sama juga macam tadi, sebabnya adalah there is more effective shielding effect. Kenapa? The increase in electron-electron repulsion as the 3D orbitals become completely occupied. So that's all for this video. Okay, in the next video we will be discussing about the isoelectronic species. Okay, thank you guys. Take care and bye-bye.